Alright guys, today's goal. The learner will understand and remember the properties of logarithmic functions. Alright, quick review here. Well, remember that would be 10 to some power equals 10 to the third, so it's 3. And then this would be e to some power equals e to the third, so that is also 3. The reason those are there is because remember natural log is actually log base e. And remember we have base to the exponent equals a number, which is the same thing as log of the base of the number equals the exponent. So that would just be -2. Simplify. Okay, well, when you divide it means you got to subtract. So 3 minus -2, -3 minus 2. You get x to the 5th, y to the -5th. Well, to make that positive, you get x to the 5th divided by y to the 5th. You got to move it down. Power to a power you multiply, so x, y squared over 2x to the -3rd. So you would be x to the 4th, y squared over 2. So let's see if we're right. There we go. Alright, what you'll learn about. Properties of logs, the change of base, graphs of logarithmic functions with base b, and re-expressing data in y. The applications of logs are based on their many special properties, so learn them well. You're not going to get an equation sheet for them, guys. Alright, product rule. Log base b of r times s is equal to log base b of r plus log base b of s. The quotient rule, log base b of r divided by s is equal to log base b of r minus. So see, multiplication means you can switch it to addition, division means you can switch it to subtraction. And the power rule, if you have log of a number to an exponent, you can bring it out front and multiply. Okay? So they want us to prove the product rule. Alright. So watch what I do here. I'm going to say let x equal log base b of r and y equal log base b of s. Well, if that's true, then r equals b to the x, s equals b to the y. So r times s would equal b to the x times b to the y, and rs would equal b to the x plus y. And if we just use the ben is equal to the log of Benny rule, you get log base b of rs equals x plus y. But didn't we say let x be this and y be that? So substitute those back in. And there it is. So now we got to use them. Yep, they did the same way. Assuming x is positive, use properties of logs to write log base 3 of x as the sum of logarithms or multiple logarithms. Okay, so multiplication tells me I can do this. But what does the power one tell me I can do? Oh, I always want to say it's log 3 plus 5 log of x. So there's those properties being used that I was talking about. See how it's 3 times x to the 5th, so you can separate it to addition, and then we have the power property, which means we can move it right down to the front. Okay? There we go. So now we're going in reverse. It says, assuming x is positive, right? 3 times the natural log of x minus the natural log of 2 is a single logarithm. So the first thing I can do here is say that's natural log of x to the third minus natural log of 2. And then subtraction means you're going to go and divide. So it's natural log of x to the third divided by 2. For a positive real number, a and b and x, with a not equal to 1 and b not equal to 1. Okay, so this is changing the base. So watch. If I have log base 3 of 2, what that's telling you is that's equal to log of 2 divided by the log of 3. You change it to log base 10 because that's what you can use your calculator to calculate. Okay? See how that works? So like if I had log base 5 of 20, it's the log of 20 divided by the log of 5. So evaluate this. Okay, so you do log of 10 divided by the log of 3. Well, I know the log of 10 is 1. So let's see. 1 divided by the log of 3. I have approximately 2.10 since I rounded. Let's see. They have 2.096, so they rounded later, but yeah. So there we go, guys. Be ready for class tomorrow.